Hi everyone, good morning. Assalamualaikum. Okay, today we continue our lesson on chapter 6, light and optic. So I will continue on topic 6.5 and 6.6 today. Means to finish the chapter 6. Okay. So for our class today, 6.5 is optical instruments. So what are instruments that apply the principle of lenses or refraction using lenses? So before that, let's refresh what we have discussed yesterday. Okay, yesterday we have discussed about image formation by lenses. So I hope you still remember for convex lens, especially for convex lens. Characteristic of image formed by convex lens depends on object distance. Okay, object distance. Wait, this one. Okay, for convex lens, when object distance less than focal length, we have discussed, you get this one, boom, virtual upright magnified. When u equals to f, you get virtual upright magnified. U between f and 2f, you get real inverted magnified. U equals to 2f, you get real inverted and same size. U more than 2f, you get real inverted diminish. U at infinity, you get real inverted diminish. Okay, so I think it's quite easy for you all to memorize the characteristic of image. Okay, so it's boom boom, rim wrist, red red. Okay, so I hope you can memorize this one because when I discuss optical instrument later, so I hope you understand better. Okay, we look at the first one, magnifying glass. Kanta pembesar, magnifying glass, the first one. Okay, using convex lens. Okay, convex lens. Okay, normally when we use a magnifying glass, we put magnifying glass closer to the object, okay, in order to magnify the object. For example, if you watch the writing is too small, you can put a magnifying glass to make it bigger. So means you must put the magnifying glass close to the object. When close to the object, U less than F. Okay, so when U less than F, what are the characteristic of the image form? Okay, remember here, U less than F is boom, virtual upright magnified. So the image form is virtual upright magnified. Okay, so when you want to draw a ray diagram for magnifying glass, this is a convex lens, principal axis. Okay, you mark focal point. Okay, both sides, same length, both sides. And then put the object here. Object here should be less than F. So this is U, this is F. Okay, so U less than F, any point. Okay, here. Okay, less than F. So when you draw the ray diagram, look again this one. Parallel to principal axis, okay, converge to F. See that here? Converge to. Okay, pass through center, straight line. So you can see that come out from the lens, it's getting further from each other. Means like diverge. Okay, dia bukan diverge lah. Maksudnya dia move away. It will never meet here. So means no image form on the screen. Form on the screen when you look through the through the magnifying glass, you will observe the image which is bigger. So the image form here is virtual image. So what you do, you just extend the line to the back, intersect here. So this is the position of the image form. Okay, so here image, virtual, upright, magnified. So this one is for magnifying glass. So you must be able to complete the ray diagram if given. Sometimes the question might come out and ask you to complete the ray diagram. Maybe they give you one or two incident ray and then you need to complete it to show the formation of image. Kena tunjuk image macam mana image tu boleh terhasil. Okay, that one is magnifying glass. We look at the second one. Okay, one is telescope. Okay, telescope we use to observe further object or far distant object, like observe a star, moon. Okay, so very far distant. Okay, for telescope using two convex lenses. Okay, the one which is used or put, we can say at the object side, we call it objective lens. So ini ialah objective lens. Okay, then close to observer's eye, we call it eyepiece. Okay, characteristic of the lenses used for telescope. Okay, you can see here objective is larger diameter, is thinner, lebih nipis. Okay, eyepiece is thicker. Okay, for lenses, the thickness of the lens showing ability to converge light means if thinner, it will converge light a bit further. So it will thicker. Okay, it's more curved, right? Less curved. The surface is more curved. So it will converge light closer. So we can see from here, focal length for thinner one is longer. For thicker one is shorter. So look at here for eyepiece, the focal length is shorter than the objective lens. Okay, ini ialah eyepiece punya, ini ialah objective. Okay, and then at this point, FO and FE is placed at the same position. Okay, so you can say this is FO, this is FE. So I mean the separation distance between the two lenses must be FO plus. Okay, so you can see from here. So this is the focal point for eyepiece and also focal point for objective. Okay, so ability to converge light actually is power of lens. Power of lens equals to 1 over length. Means the shorter the focal length, the higher the power. Or we can say the thicker one is more powerful than the thinner one. Sama macam yang pakai spek, yang pakai cermin mata. Cermin mata yang tebal tu maksudnya high power. Sama lah macam tu Okay. So yang tebal punya short focal length, higher power. Okay. Jadi nanti kita akan bincang lebih ya tentang karakteristik of the lenses for telescope. Okay. Okay, study celestial objects. Object is at infinity. Maksudnya objek ni daripada infinity sebab terlalu jauh. Star or moon is too far, so we can say it's from an infinity. So from far distance, we draw light ray passes through the lens and draw another one parallel to the first one and pass through focus point or focal point. So you dapat macam ni. Ini untuk yang further distance. Okay, pass through center, straight line. Pass through F, refract parallel. Ini actually dia terbalik dengan yang ni. Okay, ini F. Parallel to principal axis converge to F. Means kalau terbalik, okay, terbalik, F dia akan jadi parallel. Okay, pass through F dia akan refract parallel. So ini kita dapat. So you can see the two light rays meet here at focus point, focal point. U at infinity, image form at focal point. Okay, we look again here. U at infinity, real inverted diminish, actually image form at F. Okay, at focus point. Focus point. Okay, so ini we dapat image. We just mark it as I1. Then what happened next? This I1 will become object for eyepiece because we have two lenses. Light ray coming from I1, okay. This one is parallel to principal axis, so refract pass through focal point, FE. Okay, nampak sini. Okay, F. And then the other one pass here will be parallel to the first one. Okay, so you can see it produce parallel line means it's also will never meet on the screen, so no image form on the screen. The second image cannot form on the screen, so observer's eye will observe the image along the refracted ray that get into the observer's eye. So observe the image here I2. So image form at the same side of the object, meaning is virtual. Okay, as compared to the object, I2 not compared to I1. Compared to the I2, if compared to the object is virtual, inverted, because the object is here like this, if here, so image here. So it's magnified. Okay, compared to the object. Okay. Okay, itu ialah dia punya production of image for telescope. Telescope. So because of there are two lenses, so telescope, the magnification of the image or the final image I is equals to FO divided by FE. Okay, so we discuss more later. Okay, that one is for telescope. Okay, let's look at this one, microscope. Okay, microscope. Rub off this one. Okay, now microscope also using two lenses. Okay, the one which is closer to the object, we call it objective lens. The one close to eye is eyepiece. Okay, now you look at here. So it's opposite to telescope. Okay. For microscope, the thicker one is objective lens. The thinner one is eyepiece. As we know, the thicker one short focal length. So you can see here the focal length FO. Okay. For the eyepiece, ini focal length. You can see the focal length for eyepiece is longer. Okay. Okay. Now for microscope, this is the objective lens focal length, and this is focal point for eyepiece. So we can put here FE, FE, FO, FO. So the separation between the two lenses, if you plus, between two lenses is more than FO plus FE. Okay. Okay, let's look at here. Microscope is used to observe very small object like microorganism. So very small. So normally for this one we put object between FO and between F and 2F. Okay, we go back to characteristic just now. Ini U between F and 2F, the image form should be real inverted magnified. Okay. Okay, so this is the object which is smaller. Okay, parallel to principal axis, pass through F, pass through center, no refraction, straight, pass through F, refract parallel. Okay, so kita dapat macam tu. Ya, ini, ini, ini. Okay, nampak. So ini ialah light ray after passing through objective lens. After passing through objective lens. Okay, so the light ray here meet at this point, means the image will form here. We mark as I1. Characteristic of I1 is real inverted magnified. Nampak tak ini? Okay. Now I1 will become object for eyepiece. Okay, so this is the light ray coming from the I1 parallel, okay, converge to focal point. Okay, and then this one here, and then this one is here. Okay. So in front here, the image will not form on the screen. As you can see, the light ray will never meet. Light ray tu dia tak boleh meet, tak boleh meet. So what we do, observe the image through the eyepiece, extend the line because our line of vision is straight line. So extend the line, finally the line meet here. So you will observe the image form which is okay, same side as the object, means it is virtual. Selalunya kita lukis ini adalah dash line, dash line. Okay, so I2 produce is virtual inverted compared to object. Object yang mana? Ini yang objek O tu. Okay, bukan objek I2, objek O yang first tu. Okay, so dia adalah virtual inverted, okay, inverted magnified, okay, compared to O. Okay, so ini ialah microscope, microscope. Okay, now let's try to differentiate between microscope and telescope, because properties of lenses used for microscope and telescope you need to memorize, kena hafalkan. Soalan paper 1 also, okay, there's a question come out. Paper 2, okay, so you must understand this one. The similarities, apakah persamaan? Okay, Both uses two convex lenses. Yes, objective lens and eyepiece. Final image dia sama, virtual inverted magnified compared to the first object. Okay, the first object. Differences, ada banyak tips orang tips yang kita boleh nampak untuk hafalkan ini. Okay, when we talk about power, I wanted to add in power. Power equals to power of lens, power of lens 1 over F in meter. Ini formula untuk calculate power lah. Okay, so each of the objective lens and eyepiece, we can calculate the power by using this one. Okay, so for objective, we can put as power PO. For eyepiece, power is PE. Okay, so which one is higher? As we know, P and focal length inversely proportional. For telescope, focal length of objective is longer, meaning power of PO is smaller than PE. Okay, PO smaller than PE, meaning FO more than FE. Okay, separation distance between the two lenses, some put L pun boleh juga, D equals FO plus FE. Okay, object distance maksudnya U, yang first object tu, object is at infinity. Remember, U is at infinity, so object distance is E. Okay, for telescope. Okay, the first image form, real inverted diminished. Okay, at F. Position of the first image at the focal point of both lens. Position of final image, infinity. Magnification M equals to FO divided by FE. Okay. Itu untuk karakteristik for teleskop. Teleskop. Okay, microscope, you nampak tadi lenses dia terbalik. Kalau yang teleskop, yang lebih tebal ialah eyepiece. Tapi mikroskop yang lebih tebal ialah objective lens. Okay, maksudnya power of objective is more than dia. Okay, so nampak sini eyepiece. Okay, kenapa dia tulis dua-dua ni high Okay, betulkan ni silap sikit. So focal length FO less than FE. Okay, separation distance between two lenses D more than FO plus FE. The first object is placed between F and 2F. So the first image form, ini first image first image I1. Okay, I1 first image. Okay, real inverted magnified. Jadi you kena tahu tak this image characteristic of image form, actually gunakan balik yang kita buat tadi. Okay, ini first image ialah kat mana? So you dapat first image ialah RID. U at infinity, image is RID at F. At F. At focal point. Okay. Okay, kalau U between F and 2F, okay, ini dapat real inverted magnified. Okay. So position of the first image, okay, you nampak ini between focal point and optical center of eyepiece. Optical center maksudnya dekat F lah. Okay, boleh tengok balik ini Okay, between F and optical center, maksudnya less than F. real image. Okay. Jadi kalau untuk I1 ni dia akan dapat lebih daripada 2F sebenarnya. Rasa ni ada mistake sikit kat sini. Okay, a position of the first image, because first image is produced by objective lens. So maksudnya dia punya position of image is more than 2FO. Okay, lebih daripada 2FO. Position of final image infinity. Okay, untuk yang teleskop. Kalau mikroskop, tengok balik mikroskop. Okay, so ini adalah final image. Close to objective lens. Okay, maksudnya dia ada di sebelah objek. Okay, the object side. First object. Magnification, kita ambil magnification for objective lens. Kalau objective lens ni you kena kira balik MO, kira untuk guna V over U ataupun HI over HO. ME, eyepiece punya kita guna U. Okay, maksudnya product of MO plus ME, you akan dapat magnification of final image. Okay, so ini untuk this is for microscope. So you can see the difference between telescope and microscope. Okay, ada tips sikit. Tips untuk memorize. Telescope. Ni ada yang bagi tips ni. Okay, for this one you just look at E, number of E and number of O. Telescope more E than O. Okay, or we can say power of O is less than power of E. Okay, O less than E. Kenapa? Tengok bilangan E lebih. O 1 je, E ada 3. Jadi PO less than PE ataupun FO more than FE. Okay, mikroskop tengok. O ada 2, E ada 1. Maksudnya PO more than PE. So FO smaller than F. Okay, hari ni ada yang bagi cara untuk hafalkan teleskop dengan mikroskop. Tengok bilangan E dengan O. Senang. Teleskop lebih banyak E banding O. Maksudnya PO less than PE. Mikroskop lebih O daripada E. So PO more than PE. Okay. Itu adalah tips yang saya pernah lihat ada orang gunakan. So you all pun boleh guna tips itu. Okay, kita teruskan kepada exercise. Write the correct symbol more less equal in the empty spaces to produce correct statements. Okay, A. In telescope, telescope. Focal length of objective. Apa? Okay, ingat balik teleskop tadi E lebih dari O. Maksudnya PO less than PE. Kalau PO less than PE, maksudnya FO is more than, okay, so FO is more than FE. Okay, mikroskop tadi dah tengok dia punya O2 E1, maksudnya PO more than PE, but FO less than, so microscope focal length objective less than FE. In telescope, distance between lenses. Tadi ingat tak tadi? Kalau untuk teleskop, FO dengan FE point yang sama sini. So if you calculate the distance, ini FO, ini sebenarnya sendiri ialah FO plus F. Okay, so in telescope, distance between objective and eyepiece is equal to FO plus FE. Kalau mikroskop tak ya, mikroskop dia macam ni. Okay, dia ada di sini. Ini adalah FO yang lebih pendek dan FE. So kalau you total, okay, FO dengan FE ini lebih daripada distance, separation distance dia more than FO plus FE. Okay. Okay, number 2. Given the power of a lens can be calculated using power P equals if the power of objective lens and eyepiece given 1.67 diopter and 2.50 diopter, calculate distance between two lens. Ini ialah teleskop. Okay, so separation between, so FE means separation distance ialah FO plus FE. So what you do, you need to find FO dulu. So gunakan untuk formula P equals to 1 over F. You want to find what is FO. So PO equals to 1 over FO. Okay, so PO given 1.67. So what? Okay, means 1 over 1.67 lah. Okay. .599. Okay. Meter. Ini dapat dalam meter. So you convert, you dapat dalam cm ialah 59.9 cm. Okay. If you calculate for PE is 1 over FE 2.5. 1 over FE. So FE you will get 1 over 2.5. Okay. So you akan dapat 0.4 meter. 0.4 meter means 40. Okay, so you get already FO and FE. Separation distance between two lenses. D ialah 0. Oh, sorry, not 0. Okay. 59.9. Okay, so you will get is 99.9 cm. Kalau dia nak dalam SI unit, you tak perlu convert lah. You just add 0.599 plus 0.4. Okay. Okay, for number 3, distance between objective lens from object and first image is 1 cm and 2 cm respectively. Distance of eyepiece from first image, okay, eyepiece, 3 cm and 9 cm respectively. Okay. Calculate magnification of microscope. So what is the magnification for the whole microscope? Kita ada dua lenses. Means ialah product of magnification of objective multiply magnification of eyepiece. So what is magnification for objective? Okay, kita tengok ni objektif ah. Ni objektif. So dia punya image distance. Ya. So ini adalah untuk objektifnya image distance. Ini untuk object distance untuk objektif. So kita ambil objektifnya saja ya. VO over UO. So dapat 2 over sorry. Ya. 2 over 1, 2. So you dapat magnification for objective ialah 2. Okay, let's try to calculate for E, eyepiece. For eyepiece, this is the object distance, UE. And then the image form here, this is VE, 9. Okay, so you get VE over UE, you get is 9 over 3, which is, thus, the total magnification for the microscope is MO times ME. So you get 2 times 3. So the final image is 6 times bigger compared to object. The first object, O, compared to first object, O. So this is the magnification for the microscope. Okay. Okay, number 4, a telescope is an optical instrument with 2 lenses that can be used to observe distant object yang jauh. Using your knowledge, suggest suitable characteristic for the telescope and give reason. Okay, so when we talk about this one, this is like a paper 2 essay. The 10 mark one characteristic, you can just make a table. Buat table. Okay. Okay, so trying to list out at least 5 characteristics. So for the eyepiece, you can discuss in terms of the lenses, the power, okay, power of lenses, objective and eyepiece, okay, and then the length of the telescope, okay, separation distance, normal adjustment to find the image which is sharp and clear. Okay, itu adalah berkaitan dengan teleskop. Okay, ini adalah teleskop. Teleskop, E more than O. and then FO more than E. Okay, first maybe you bincang tentang power. Second, focal length pun boleh. Okay. Power of objective lens is smaller. Of eyepiece is larger. Okay. Okay. Objective lens is okay. Eyepiece is thinner. Five, diameter lens is larger. What else? Six, separation distance. Okay. Between eyepiece and objective plus FE. Okay, so kita boleh bagi reason di sini. Power of objective lens is smaller. So, focal length is shorter. Power of eyepiece larger. Focal length is sorry terbalik. Sekejap. Inversely proportional. Longer. Shorter. Objective. Kalau you nak repeat balik pun boleh juga sebenarnya. Can focus the image. To produce it at a focal point. Is thinner to produce the diameter is larger capture clear and separation FOFE also to produce clear or sharp image under normal adjustment. Okay, so you all boleh buat dalam bentuk table. Okay, kalau aspect diberikan, you just follow the aspect lah. Okay, so I just write it like this. Okay, characteristic of image. You want to add in another one like image form is virtual. Okay, upright, magnified dan sebagainya, you boleh masukkan. Okay, that one is for optical instrument. So memang you kena ingat lah. Okay, no need to memorize the drawing here. No need to memorize. Okay. If question come out, it just asks you to complete the ray diagram. Okay. Okay, so we go to the last part of this chapter 6. 6.6, image formation by spherical mirror. Okay, for lenses we have done. Now we go to mirror. Okay, as you know, mirror will apply a concept which is different from lenses. Mirror will apply concept of reflection. Mirror is reflection, same as a plane mirror. I think a plane mirror you have studied in lower form. So now we just discuss about spherical mirror, curved mirror. Okay, so there are two types of curved mirror, convex mirror and concave mirror. Okay. Okay, for convex mirror, ini mirror ini dia punya surface. Ini dia punya surface. Okay. Ini okay. So ini panggil convex. A light ray, okay, coming and reflect. Okay, diverge. So ini convex mirror dia punya properties dia diverging mirror, diverging mirror. Okay, macam ni kalau diverging, kalau kita ada yang mirror, so let's say kita ada light coming like this. Okay, we draw tangent, draw normal line. Okay, so apa berlaku? Angle I reflect same angle. Reflect same angle. So you can see the reflected one like diverge from the mirror. Okay, diverge from the mirror, it seems like coming from one point mirror, which has focal point of the mirror. Okay, so that's why for convex mirror, we call it diverging mirror. Diverge. So bila diverge, the light will go to larger area. Go to larger area means if you observe here, you also can see the object. If you observe here, you can see the object. If you observe the object, means the field of vision is wider, lebih luas. Okay, now you concave. Concave, macam cave lah kan, concave dia curve macam tu. Okay. Okay, dia curve macam ni, dia punya surface. So let's say, okay, kita normal line. Actually, when you draw, no need to draw normal line. I draw here just to show why it become like this. So actually, we apply the same concept of reflection. So ini adalah tangent, this is the normal line. This is tangent, this is the normal line. Okay, so same thing, this one will be reflected macam ni. And this one will be reflected like this. Okay, so dia converge to one point that we call it focal point. Okay, so untuk ini you boleh nampak kalau dia converge, okay, converge means you observe a narrow, okay, narrow field of vision. Sebab dia reflect kat sini saja, reflect masuk sini. Okay, so ini narrow field of vision. Okay, so that's why ini panggil converging mirror. Okay, converging mirror. Okay, kita tengok diagram. Important terms, sama macam lenses. Okay, this is convex. Convex. Let's say there's an object here. Distance from mirror to object is u. Let's say image form here. Distance from image to mirror is v. F is focal point, so distance between F and center of the mirror is focal length. Focal length. And then 2F. Okay, 2 kali F, also known as center of curvature of the mirror. What is this center of curvature? Let's say the mirror is coming from a spear-shaped mirror. Out lah, keluar. Okay, this is mirror. If you cut out this side, so it will form convex. Okay, if you cut out side, you will get concave. Okay, so center of the circle is O. This is radius of the circle. Okay, radius of the circle, the point or the focal point is midpoint of the radius. Tengah-tengah. Okay, means 0 here is 2F. Ataupun kita panggil dia center of curvature. Means center of curvature is 2F. Okay, ini panggil center of curvature lah. Okay, O ni sebenarnya center of curvature untuk convex, center of curvature untuk concave. Okay, nampak tak? Dia macam ada satu big sphere kat sini. Big sphere. Okay, jadi C ni adalah center of curvature. Okay, dia adalah 2 kali focal length. And PC PC ialah R. Okay, R. Sama juga dengan concave. Concave, so ini adalah dia punya pole atau P, center pembulan. Focal length, F, C ialah 2F. Okay, object distance U. Okay, and then image distance V. Okay, kita tengok definition. Principal axis, straight line through C and pole of spherical mirror. Okay, ini adalah C, pass through C and pole. Maksudnya ini kita punya principal axis. Center of sphere produces concave or convex mirror. Maksudnya center ni kalau you tengok sebelah sini, ini adalah convex. If you look from here, this is concave. Jadi the same center of curvature will produce concave or convex. Okay, radius of curvature between P and C. Ini radius P and C. So dia adalah radius of curvature. Focal point, points on principal axis for concave mirror, light converge at this point. For convex, light appears to diverge from this point. Sama juga concave tadi kita panggil dia converging mirror. Convex, diverging mirror. Object distance, distance between object and P. Image distance, distance between image and P. Focal length, distance between F and P. Okay, nampak ni F and P F and P adalah focal length. Okay, characteristic of image. Same as the lens, kita juga ada konsep real or virtual, inverted or magnified, magnified or same size or diminished, sama. Okay, now we look at characteristic of image form below. Okay, mirror, I think you understand. For mirror, okay, kalau plain mirror, the image always virtual. But for curved mirror, especially for concave like this, you will get a real image. Okay, because for concave mirror, ini concave, characteristic of image depends on view. Okay, for convex, there's only one characteristic of image, which is BUD. So dia terbalik dengan lenses, terbalik dengan lenses. Okay, look at this one. Ini image form behind the mirror, maksudnya in the mirror. So image is virtual. Dua-dua nampak upright. Ini upright, size bigger, so magnified. Second one, object. Ini image still in the mirror, so virtual, upright, diminished. Smaller, image smaller compared to object. Concave, image form in front of the mirror. So untuk mirror dengan lens, dia berbeza. Kalau sebelum ni you lihat lens, object, screen. Okay. Maksudnya kita lihat adakah image form on the screen. Kalau form on the screen kita sebut dia real. Itu untuk lens. Tapi kalau mirror, dia apply different concept. Okay. Lenses, light can pass through the lens. But mirror, light cannot pass through lens. It will be reflected. So where we should put the screen, kalau ini adalah mirror, you kena letak objek screen di sini. Screen letak sebelah yang sama. Okay, so means if it reflect and meet in front of the mirror, image will form on the screen. On the image form on the screen, we call it real, inverted, diminished. Okay, so itu untuk concave. Tapi dia different lah karakteristik. Ini just one example saja. Okay. Nampak tak Untuk yang ni, okay, yang concave ni, ini yang pertama pun concave juga concave. Sebab concave dia boleh jadi virtual ataupun real, depends kepada you, di mana you letak objek. Tapi untuk convex, satu saja. Mana-mana tempat you letak objek, you akan dapat same characteristic, BUD. Virtual, upright, diminished. Okay. Okay, kita lihat sini, image formation by spherical mirror. Technique of drawing sama juga, macam lenses. Okay, let's draw the first one. Ini adalah convex. Yang atas ni convex. Okay, light ray parallel to principal axis. It will diverge from F. Okay, diverge from F. So ini adalah reflected ray. And then another one, directed towards C, center. Ingatlah, kalau satu circle, ini O, kalau light ray directed to, dia adalah straight. Sama di sini. Okay, so dia pass through C and then dia akan balik also along the same path. Nampak? Reflect balik along the same path. Macam tak ada change in the path travel. Okay, tapi direction dia terbalik lah, reverse direction. So you dapat ini reflected ray. So where is the image? Kalau macam ni, image not form on the screen. It will never meet. So what you do, extend to the back. Sambung ke belakang. So dapat image di sini. Image in the mirror. So yang ni adalah virtual upright diminished. Okay, VUT. Jadi untuk convex, mana-mana U, any U, mana-mana U dapat same characteristic VUD. Okay. Look at the second one. Ini adalah concave. Concave, this is the parallel light rays. Parallel will be reflected towards F. Okay. Beza dengan concave. Concave reflected from F. From F. Yang ni reflected towards F. Sebab F dia adalah real. Okay. So you dapat macam ni. Okay. And then the second one, pass through F. Pass through F, reflect parallel. Pass through F, reflect parallel. Maksudnya terbalikkan saja ni. Nampak tak ni? Kalau pass through F, dia akan reflect parallel. Parallel, reflect pass through F. Pass through F, reflect parallel. Okay, pass through F, reflect parallel. And the two rays meet here. So means image form here. Okay, so image form here is real image. Okay, inverted magnified. Okay, real. Okay, ini contoh. Okay, summary of image formation of mirror. Jadi kalau convex, dia terbalik je dengan lenses mirror. Jadi you hanya ingat saja kalau convex just try diminish. Okay. Kalau concave depends on U. Okay, kalau you letak di sini first one, U less than F, you dapat virtual upright magnified. U equals to F, you dapat virtual upright magnified. Ini ialah at infinity. Okay, and then U between F and 2F, you dapat real inverted magnified. And then C, center of curvature, maksudnya ialah 2F. Okay, U equals C, you dapat real inverted same size. U more than 2F, you dapat real inverted diminished. U at infinity, you dapat real inverted diminished at F. Okay, buat tak? Jadi hubung rim-rim red sama macam convex lens. Okay, kita boleh cakap dia similar to convex lens. Jadi kalau you hafalkan ini, jadi you boleh hafal sekali convex lens dengan concave. Cuma ray diagram tak sama sebab lenses apply refraction, untuk mirror dia apply reflection. So dia tak sama. Okay. Okay, tengok soalan exercise. Complete the ray diagram and state characteristic of image form. Okay. So ini adalah convex. Okay, ini concave, tahu beza concave. Masuk ke dalam macam tu, ini convex. Okay, kita boleh draw parallel to principal axis. Apa berlaku? Diverge from F. Dari F draw macam ni, and then draw out. Use ruler, use ruler. Okay. Kalau pass through F tak cukup ke bawah sangat. Okay. Let's say directed towards C. Directed towards C, dia akan reflect balik macam ni. Okay. The two light rays will never meet in front here, so no image form on the screen. So what you do, you just extend to the back. You will get image form here. Okay. So image form here for convex, as you know, is always So usually the frequency is for upright. Okay. So ini untuk convex. Kita tengok concave. Okay. Parallel to principal axis, reflected towards F. Pass through F. Saya guna warna lain. Okay, pass through F, reflected parallel. So meet dekat sini, image form di sini. Patutnya tempat sama lah ni, saya punya drawing sengit-sengit. Saya padam balik. Sebab image dekat C, maksudnya mesti C juga. Ini saya betulkan sikit tanda-tanda. Tak boleh. Ya, diagram saya. Sengit. Okay. Jadi objek yang kita dapat ni inform on the screen, so dia adalah real, sama size same size. Okay, so ini convex, ini concave. Untuk convex, dia punya F dengan C dia adalah virtual, dia di dalam mirror. Itu beza dia. F ni kat luar ni tak boleh sebab dia tak real. Dia tak real. Dia adalah virtual. Kalau you tengok balik sphere ni tadi yang saya lukis adalah center of the, sini adalah X, sini adalah concave. Okay. Jadi kalau you lukiskan F, okay, untuk convex F dia ada di sini, di belakang. Di belakang. Atau concave. Ini sini. Ini tak ada. Okay, itu beza dia. Ini convex. Bahagian ni convex. Bahagian ni kita panggil convex. Bahagian ni ialah concave. Okay, tahu? Boleh ya? Okay, kita lihat lagi concave. Beberapa distance. Ini U less than F. Kita nak tengok. Kalau ikut yang table yang saya buat, yang hafalkan tadi, U less than F, dia akan dapat virtual upright magnified. Betul tak? Kita check dulu ya. Okay, parallel to principal axis, refract pass through F. Okay, reflect pass through F. Okay. Kalau C punya 90 degrees to the mirror, maksudnya dia akan pass through C, so it will reflect like this. Dia akan C. Okay, directed degrees to mirror, reflect pass through C. In front of the mirror, the two light rays will never meet, so no real image. Tak ada real image. So what you do, extend that sample Okay, so it will meet here. So image form here. Okay, so you dapat the image form characteristic is virtual upright. Okay, so itu betul tak? Betul kan? Jadi kalau you tahu karakteristik ini, you sudah hafal. So lukis ray diagram mestilah betul ikut karakteristik tu. Okay, sekarang kita tengok di sini. Ini ialah 2F, maksudnya U more than 2F. Kalau U the image form is real inverted diminished. Kita lihat betul tak kita dapat. Okay. Ini ialah parallel to principal axis refer to F. And then second one I use different color. Okay, pass through F, reflect balik parallel. Okay, so image form di sini. Image kat sini. Okay, so form in front of the mirror maksudnya real. Okay, upside down, inverted, smaller, so diminished. Okay, so we get the same characteristic. So means if you are able to memorize, lagi senang lah kerja you. So real. Okay, tengok kalau U less than F, saya tak boleh guna yang ni, yang hijau ni. Yang hijau ni tak boleh sebab F kat sini. That's why saya guna yang ni. 90 degrees. Jadi rule of drawing ada 3 ray yang you boleh pilih. Parallel to principal axis, 90 degrees to mirror, and pass through focal point. Okay, tiga cara untuk lukis. Jadi ikut kesesuaian. Kalau macam ni lebih sesuai parallel to principal dengan 90 degrees to mirror. Kalau macam ni sesuai parallel and pass through F. Lebih senang. Okay. Kalau you nak buat yang 90 degrees pun boleh, tak ada masalah macam ni. Okay, kalau yang 90 degrees tu maksudnya dia akan reflect balik ke C. Okay, macam ni. Boleh, tapi make sure betul lah 90 degrees tu. Okay, 90 degrees, so dia akan reflect ke C. Jadi kalau tak confident, jangan lukis. Yang warna merah ni. Okay, so tu yang senang cara lukis. Okay. Okay, image formation by spherical mirror. We look at some of the application. Cosmetic mirror. Cosmetic mirror, kita nak image become bigger. Ingat kalau convex mirror, image dia sentiasa finish, sentiasa kecil. Jadi kalau you nak guna application, nak image besar, maksudnya tak boleh guna convex. Okay. Kalau you nak besarkan image, kena guna concave. Sebab concave dia boleh dapat image besar. Sebab dia punya image dia depends pada you. Dia ada banyak dia ada rim. Okay. Dia ada zoom. Maksudnya boleh dapat image yang magnified. Okay, untuk concave. Jadi kita tengok lagi. Kalau cosmetic mirror, magnified image for applying makeup. Okay, ini semua kita guna concave. Okay, sebab kita nak concave ini semua concave. Concave mirror. Lagi satu teeth betul. To examine teeth mirror that dentist use. Ini juga to make it bigger your teeth. Mesti pakai concave. Mungkin lagi at a distance. Okay. Ini pun pakai concave. Okay. Saya boleh light tu jadi bergerak lebih jauh. Okay. Headlight of reflector. Dia concave. So kalau dia datang dari F, dia akan reflect balik parallel. Okay, so maksudnya you boleh letak bulb tu dekat focal point pada reflector. Ini panggil reflector. Kalau lampu tu dia ada reflector, so you letak di F, bila light go to the mirror, it will be reflected parallel. Kalau parallel, dia boleh travel further distance. Maksudnya light tu akan pergi jauh lah. Light akan pergi jauh. Okay, kalau convex, kita ada sini, contohnya blind spot mirror, sharp corner of the road. Widen field of vision of driver. Boleh lihat image of the object behind obstacle. Nampak yang terlindung tu boleh nampak kalau letak satu mirror situ. Security mirror, surveillance purpose dalam kedai kedai dia letak dekat satu spot convex, so dia boleh nampak semua part of the kedai dalam mirror tu. Kenapa? Sebab dia widen field of vision. Image becomes smaller. Kalau image smaller means can look more area. Okay, can look at more area. Itu maksudnya widen field of vision. Okay, gunakan convex. Okay, jadi image kecil. Kalau image kecil boleh nampak banyak lah. Okay, boleh nampak area yang lebih besar dalam kedai tu. Okay, rear mirror provide wide field of vision, enable driver to see vehicles coming from behind. Jadi maksudnya boleh nampak kawasan yang lebih luas melalui mirror ini. Okay, can see from the side, from this side, and also behind. So widen field of vision. Okay, so ini ialah convex. Okay. Okay. So you must know this one also, because can come out in paper 1, paper 1, okay, ataupun maybe some application discussed in the paper 2. So for this, until now, I have done 6.5 and 6.6. Okay, so for spherical mirror, same as lenses, you need to memorize. Kalau boleh, better memorize lah. Characteristic of image depends on its object distance. Okay, so untuk mirror, there's no calculation. Hanya untuk lenses ada. I think that's all my session today. So I have covered everything for chapter 6. I have sent here 3 videos, so you can watch the video starting from 6.1. The first video is 6.1 and 6.2. Second video 6.3 and 6.4, and this one is the third video 6.5 and 6.6. Okay, so that's all. Bye.